Hey there everyone, and welcome to a new video on the Future Programmer YouTube channel, this one on the random module of the NumPy package in Python. Without further ado, let's go ahead and dive into it. Generating random values and random distributions is a very common task in data science when we want some dummy data to play with or test some algorithm with. NumPy's random module gives us the ability to perform these operations. As always, let's import NumPy as MP. The recommended way of generating random values distributions is with a generator object in NumPy. Now, there are other ways of doing what we're about to do, but NumPy recommends that we do this in the following way. So we will construct a generator object using the numpy.random.defaultRNG function. So RNG is equal to numpy.random.defaultRNG. So we get this generator object, and let's now use it to create some random data. So an instance of a generator object provides methods to generate random data. The size parameter, which is in all of these methods, is the shape of the output array. If size is none, or if it is not given, then the method will just return a single value instead of an array. So numpy.random.generator.integers is going to take a parameter low, a parameter high, and a parameter size. And this will return random integers, whole numbers, between low and high, inclusive of low, but exclusive of high. So this method called right here, rng.integers, so this is our generator object, and we're calling its integers method, passing in low as 1 and high of 10. So this is going to give us some integer between 1 and 10, including 1, but not including 10. So we can get something such as 3. And then we say rng.integers and we say 1, 10. So this is the same thing as before, but the difference is size is equal to 2, 3. So we pass in a tuple as the size argument. So this tuple right here is going to be the shape of the output array, which you can see right here. This has a shape of 2, 3, two small subarrays, and 3 elements in each of these small subarrays. So 2 rows by 3 columns, basically. And then we have numpy.random.generator.random. So we have the random method, which takes a size parameter optionally and returns numbers in the interval 0 to 1, including 0.0, but exclusive of 1.0. So rng.random is just going to give us one number, and rng.random with a parameter passed in, an argument of 4, 3, is going to give us an array with 4 rows and 3 columns. And we can see all of these values are between 0 and 1. And now let's talk about the choice method. Generator.choice takes a bunch of parameters. A is going to be the array or list that we randomly choose our elements from. So this method is going to randomly choose some values from the list or array A. The size parameter we already talked about. The replace parameter is going to determine whether or not our sample is chosen with replacement. If true, which is the default value, then a value can be selected multiple times. If it is false, then a value can only be selected one time. P is going to specify the probabilities of selecting each element in the array or list A. If it is not specified, the probability of each element being chosen will be the same, so the distribution will be uniform. So here we have an example, rng.choice. We pass in 2 values, or 1 value, but it's a list of 2 values, 1 and 2. So we can see we get 1, we can also get 2, but in this case we got 1 since it is random. Here, we print out rng.choice, we pass in a list of 6 numbers, size is equal to 2, 3. So this will give us an array with 2 rows and 3 columns, and we can see all of these values are chosen from this list right here. Line 4 is very similar to line 3, with the only difference being replace now equals to false, whereas here, replace is equal to true. The difference is that if we take a look here, we can see that 5 got chosen twice. Now this is all random, so I didn't really do anything to cause that, but 5 here coincidentally got chosen twice, and so did 6. In this array, however, every number appeared only once. You can kind of think about the choice method as we have these values. So we will write each of these values on a piece of paper and put it in a box. And the replace method is the replace parameter is going to determine when we take values out of the box, are we going to put it back in? Now in this case, we do put it back in. So after we take out the 5, we'll put it back into the box so we can possibly take it out again. Whereas here, we don't put it back inside of the box. So after we chose 3, it is no longer a possibility for us to get it again. There's one thing to note though, if size is not valid. So in this case, if I have, let's say, if I have 2, 4, so this will require 8 values, but we only have 6 options to choose from. We can't possibly generate 8 values without replacement from 6 numbers. So we'll get a value error saying that cannot take a larger sample than population when replace is false. So we have to ensure that our size is correct. And then we have rng.choice 1, 2, 3, size is equal to 2, 3, and then we have the p parameter. Now this will determine the probability of selecting each of these elements. The probability of selecting 1 is going to be 0.1. The probability of selecting 2 will be equal to 0.1 as well. And the probability of selecting 3 is 80%. So these are our percentages. This is 10%, 10%, and 80%. So we can see, indeed, 3 got chosen a lot more times because there's a 8 times a higher probability of choosing 3 than choosing 2 and then choosing 1. So we get 3 a total of 5 times and 1 only once, and we didn't even get 2 in the entire array. Lastly, we can also see that rng.choice is not limited to just numbers. We can also choose strings such as A and B, and we can also specify probabilities. Here we actually got the 0.1, the 10%, which is B. I'll put it right here. But if I run this multiple times, we can see usually it is A. Now let's move on to talking about shuffling. Now, if we want to randomly shuffle the order of an array, we can do this using 2 methods, the generator.permutation method and the generator.shuffle method. The permutation method is going to shuffle an array and return a copy of the data in a randomly shuffled order. The shuffle array, on the other hand, is going to shuffle an array in place and return none. So the shuffle array is going to modify the array that we pass in, whereas permutation is not going to do that. It will just return a copy of the shuffled version of that data. So here we have an array, numpy.a range 10, so it'll be the numbers between 0 and 9. We print it out, and we print out rng.permutation array, so this is our generator, and this is its permutation method. We pass in array, and we can see we get a shuffled version of the same numbers from 0 through 9. But on line 4, we print out array again, and we can see it is not changed because this is going to return a copy printed out here, but not modify the array, so it remained in order from 0 through 9. On the other hand, we have rng.shuffle. In this case, we can see we don't print this out. Instead, this is going to directly modify the array right here. So we can see line 9 and 11, the 2 outputs are different. This is in order, and this has been shuffled. The last thing we're going to talk about is a cool advantage of using NumPy to perform random generations, and it is producing distributions. So the advantage of using NumPy's random module instead of Python's default built-in random module is NumPy can draw samples from distributions randomly. And here is just a few of the many distributions that we can draw random samples from. So here we can see a normal distribution with mean 3 and standard deviation of 0.5, and size here, of course, we can pass in 2, 3, but we can also just pass in 2 if we want 2 values. And we can see 4.16 something and 2.49 something. Binomial distribution, n, p, size, and we have geometric distribution probability of 0.3. Size is not given here, so we just got a single value. And lastly, a chi-square distribution. We have a degree of freedom, 5 degrees of freedom, and size being just 4, so we got 4 values. Of course, don't worry about these distributions if you don't know what they mean. That's not quite important. just if you need to use those in the future, you will know where to find them. You can use the RNG dot and then these methods to do that. And as an added bonus, let's just plot these distributions out for fun. Now this is going to use the matplotlib package, which I have a separate video series of if you want to learn that. But let's just for fun plot these distributions out, and we can see the normal distribution centered at 3 with a with a standard deviation of 0.5. And you can actually see there's a lot of values that are in this data set that I created, a total of 100,000 data points plotted here. This is a binomial distribution, a geometric distribution, and a chi-squared distribution. To summarize in today's lesson, we talked about NumPy's random generator and how we can use it to generate random data, shuffle data randomly, and generate random distributions. And that's it for this video. If you have any questions, feel free to leave them in the comment section down below. I hope you found this video helpful, which if you did, please consider subscribing down below and giving this video a thumbs up. With that said, thank you very much for watching, and I hope to see you in more programming tutorials in the future. In the meanwhile, happy programming!